We are in the series of logic building, and today problem is longest substring without repeating characters. So that's the LeetCode problem, and this has been asked in many companies like Facebook. So let's try to understand this problem, and we'll see the solution. It's a medium level problem, and it's saying longest substring without repeating characters. So example is here. If you see the ABC, so this should be longest substring also without repeating. So it's a ABC. So till here, its a length is 3, ABC. And if you move to the A, then in this case, if you move to the A, that's a duplicate. So we can start with again BCA. So BCA is again max is 3. So in the similar way, if you move each character, and I will see the max. So max or longest substring without repeating character is 3. In this example, it's a 1. So here you can see the B, and another one is repeated. So how will you do that? Let's see another example. P and W is a length is 2, and again if you move to this place, that's a duplicate. Then we can start with W. We can start from here, WKE. So WKE, so the answer is WK with the length is 3. Notice that the PK is a subsequence and not a substring. Okay, PKW is PWKE. So let's say PWKE. Yeah, so we need a substring, right? Not a subsequence. So from here, yeah, WKEW, again W is repeated, so KEW. So anyway, so max is 3 here. So how will you do that? So one way is we can have the for loop, 2 for loops. Like one for loop you can iterate through each character. Like let's say one for loop we can fix the pointer here A, and next for loop you can try all the combinations AB, ABC, ABA, ABB, ABC. Try all the combinations. As soon as we'll see the duplicate value, then we can break the inner for loop. Like let's say in an inner for loop is find A and then AB. We can store in a map, or we can set, like we can say set here AB, ABC, and we'll keep checking. When we store that, we'll keep checking whether that another letter present there or not. If already present in this map, then we can come out of there. But that is order of n square, but we can achieve in that way. So another efficient solution we are going to try with 2-pointer technique. So in a 2-pointer technique, we'll put the left pointer and the right pointer, and then we'll see the solution. So what we do in the beginning, here, like let's say in this example, like PWKW, in this example, we'll fix our left pointer in a P and the right pointer also in a P. Let me do this thing with a example here. So what we do, our left pointer here in a P. So here I can say the left pointer here, and the right pointer also in a P the first time, and then we'll iterate through each character, and we'll see the P, and when we encounter this P, we store that P in a map. So somewhere in a map we'll store P. Then we'll move to R pointer to W. So R is here. We can store W in also in a map. Then we can move again R pointer to next. So R comes here. So as soon as we come here, will check whether this W exists in a map or not. So when we, and also one more thing, like when we store this P, we also store the index, and for the W we also store the index. And when we come to this place, we'll check whether this W exists in a map or not. So we know the W already exists. Then what we do, we'll get this index 1. So index 1 is till here, till W, this here. And in this case we found the repeated number. So in this case we'll delete PW, like we'll delete all the letter from left pointer to this index PW till W. We'll delete all this from map. And also before deleting, also in every stage we are calculating, what is the max length. So as soon as we put the P, the max length is 1, and W, put max length is 2. And okay, so this time we delete it till PW, and then we'll move the left pointer to the to the 1, like whatever the index is there. So index plus 1. So index was, the index was here 1, because we found the repeated, we found this W at index 1. So we'll move the left pointer in this place. Okay, and we already deleted PW, so the map is empty. So this time we'll store W here, W, and index is 2. So 0, 1, 2. So index is 2, and then again we put K, and index is 3. Put the E, index is 4. So E, and we are also moving this R also. So R is here, and index is 4. And we also calculated the max in a map also. Then this time, we already have the 3 items in a map. So max is already 3. Max item is 3. So now we move again R to this place, W, and we know the W is already in a map. So what we do, we'll try to find the index of this W. So here in this case, index of W is 0, 1, 2. So 2, index is 2. So we'll delete all the items from the left pointer to this index. So this from the map, actually in the map there is a WKE, and from the left pointer to the index. So the left pointer is also here, and index also, whatever the index we found for the W, that's also here. But anyway, we'll delete this W, and from the map we'll delete from the W. Okay, and then put the W here again, W, and the index is, it's a 5. Okay, 5. And in this case also we calculated the max value. So in this way, if you use the 2-pointer technique, then we can easily find the max substring without repeating the character. So let's use this technique and try to solve the problem. Okay, so I'll say the left pointer is 0, and right pointer is also 0, and for R less than length of string is, come here. I will also create one map. So for the map, I'm saying one DS, data structure, is a make map, and it's going to store the character. So for the character, I'm saying it's a byte, and then it's also store the index. So for the index, it's saying int. Let's create a function. One is like max function. So max ab int return int. If a greater than b, return a, else return b. and create the one variable. This is for the max variable is equal to 0. Okay, and we also move the R at the end, processing one by one, so we can move the R, or maybe we can change this thing like this. R is equal to 0, then R less than length of s R plus plus. So in this case we do not have to define R here, but anyway R is already defined and started with the pointer 0. Okay, so the next step, we'll check in a for loop. Also at the end we also put ds. Inside the ds we store this character one by one, so this s R. So let's say like this ds and sr. So sr, inside the ds we are going to store this character, so sr will be that character, and then we can store the index. So index is R, so R is starting with the 0, so we can put that character index here, and also we'll check the max, whatever is the max inside this. So m is equal to max of the length of the map, so length of ds, and whatever is already in m. So we'll keep maintaining the max item here. So the other logic, the main logic is here. If we'll check, like if we check this character already exists in a map or not. So ind and then okay, and then this one. If okay, that means if it exists, then what will you do? We'll delete all the items from the left pointer to index. So I can say for I is equal to 0, and then I not 0, I is equal to left pointer, and then I less than equal to index, and then I plus plus. I think that's all. I from the left pointer, and then less than is equal to index, and I plus plus. Delete the item from there. So delete. That's a s and s I. Okay, so we deleted the items till index, and then our left pointer will be l plus, or left pointer will be directly index, whatever the index we got, index plus 1, index plus 1. Okay, so that's all. Let's try to run and see whether it's pass all the test cases or not. So run it. Okay, so from the, we want to delete this from the map, so we didn't mention, so that's why it's complaining. Let's run it again. Okay, at the end we need to return also, so we want to return m, so that's the max. Return m. Let's run it again. It's accepted here. Let's try to submit and see if any test case fails, or let's take it. Nice, so it's got accepted. Let's see the Java solution. So it's a similar concept. So the Java solution is a left pointer here, and the max value, I create the hash map. We can use the, yeah, I just try to use the similar logic what I used in a Golang, but in a Java we can also have a hash, but you can use hash, but we need the hash map anyway because we have to store this index also. The same logic, r0 less than is a string r plus plus, and then we're checking whether, and here like we're finding the max also, then we're putting that character one by one in a map, and we're checking whether that character exists or not. If it exists, then in that case delete from the left pointer till index, and the left pointer will be index plus 1. So that's all for today. Thank you.